All right, let's continue on with probability distributions, and we are going to look at creating the probability distribution table for the roll of a dice and for the sum of the two dice. Okay, the diagram below on the left shows all the ways in which a pair of dice can land, written as an ordered pair in the form the result of the first and the result of a second. So the first roll was a 1, the second one was a 2, and so forth. There are 36 possible equally likely outcomes, and suppose we're interested in the sum of the dice. So these are all of our possible outcomes. So these are our outcomes. But the sum is going to be our event. Okay. All right, so the first thing we want to do is let's go ahead and fill out this table and see if we can do the sum. 1 plus 1 is 2, 1 plus 2 is 3, and so on. 1 plus 5 is 6, 7, 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, 7, 8, 9, 10, 11, and 12. Okay, so let's see what we've got here. Well, you can see on here that the sum of 2 came about, that there is only one of those. There is only one way that you can get a sum of 2. So the frequency, there is one way to get a sum of 2 out of the 36 outcomes. Then the sum of 3. There are 2 ways that you can get a sum of 3. So 2 out of 36, and it gives you this probability. Now for the sum of 4, there are 3 ways that you can do this. So your probability is going to be 3 out of 36, which is 0.083. And then you're going to continue down with that. So we can do a sum of 5. There are 4 ways to do that. 4 out of 36 is 0.111. I'm going to use up all the colors on this one. A sum of 6. There are 1, 2, 3, 4, 5 ways to do that. 5 out of 36 gives me 0.139. Then we have a sum of 7. There are 6 ways to do that. 6 out of 36 is 0.167. Okay. Now notice they took it to 4 places here. I quit at 3 because I write big and I ran out of room. Okay. Then we have a sum of 8. There are 5 ways to do that. Notice we've already done that probability. Then we have a sum of 4. I'm sorry, a sum of 9, which is the same as the sum of 4. Whoops. Which gives me 4 out of 36, which is 0.111. Then we have a sum of 10, There are 3 ways that that can happen, so that's 3 over 36, which is 0.083. To get an 11, there are 2 ways to do that. 2 out of 36 is 0.0556. And finally, to get a 12, there is 1 way to do that, which is 1 out of 36, which is 0.0278. Now notice, without the rounding and everything, they went ahead and did that for you, is the sum of the probabilities equal 1. Why? When you roll 2 die, the result is certain to be one of the events. Okay. All right, and our last example on this very long section is the table at right shows the gender and political party of the 100 delegates at a political convention. Suppose you encounter a delegate at random. Now notice I left some blank space in here, okay, because I like to, when I'm dealing with this, I like totals. So 21 plus 25 plus 6 is 52. 20, that gives me 48. The total is 100. This is 49. This is 41. This is 10. So now I know exactly what I'm looking at. This is total Republicans, total Democrats, total women, total men, total delegates. Okay, so let's find the probability that we meet a man. Okay, so the probability of a man is the total men divided by our total people, which is 0.48. What is the probability that you meet a Republican? So the probability of a Republican, well, let's see, our total Republicans, this is 49 out of 100, which is 0.49. What is the probability that you meet a male Republican? Okay, well, male Republicans, so probability of a male Republican, there are 28 out of 100, which is 0.28. And finally, what is the probability that you meet someone who is not a Republican? Okay, once again, there are 2 ways we can do this. So the probability of not a Republican is 1 minus the probability of a Republican, which is 1 minus 0.49, which is 0.51. Well, if you want to also figure out this, if it's not a Republican, then you're looking at the probability of a Democrat or an independent, which is going to be a Democrat or an independent is going to be 51 out of 100, which also gives you 0.51. Okay. Wow, that was a long section. Okie dokie. We'll see you again for the odds portion of this.